All right, hello Vikings. Hope everybody's doing well out there. Going to make a video here on the worksheets for the week. Go over some of the example problems. No, you do not need to adjust the video. This is Mr. Couch. I do have a mohawk. We decided as a staff, Miss J decided that we need a little more school spirit, so we're going to do some spirit days this week, and you know if Mr. Couch is going to participate, he's going to go full in, be fully committed, so rocking the mohawk. You guys will have to leave me some comments in the video, or for the video. Let me know what you think. My new hairstyle, maybe I should keep it going for the next week here or so. Alright, but anyways, so starting off, the congruence and similarity worksheet. The first part here, complete each congruence statement by naming the corresponding angle or side. So we've got triangle IJK is congruent to triangle IBC. Then it shows us the triangles here, and this one's fully marked with both the angles and the sides. The question is actually clear down here at the bottom below the triangles, where it says that K to I would be congruent to what? And so the little line on the top again means that it's a side length. So we're wondering what side length, if K to I, which would be this side here in this triangle, would be congruent to what side length in the other one? Well, remember, there's a couple ways we can tell. So K to I has 3 markings on this triangle. So if I look in the other one, 3 markings in the other triangle. I can either call it C to I or I to C would work. And put a little line over the top. So another way I would be able to tell that as well is looking at the congruent statement. K comes last in the first triangle's ordering of letters, and circles back to I at the first. C comes last here and circles back to I at the beginning of that one. So that's another way to be able to tell is by using the congruent statement. For number 3 here, now we've got triangle MKL is congruent to triangle SLT, and we want to know angle M is congruent to what angle in the other triangle then. So if I mark my angles real quick, so triangle MKL, so M would get a single, K would get a double, and L would get a triple. Marking. And then if I do the other one, S gets the single, L gets the double, and T gets the triple. And again, that's just in accordance to the way the letters were ordered in the congruent statement. I'm just following that pattern, going 1, 2, and 3 markings in accordance with that. Okay, so angle M then, well, angle M got the single mark over here in this triangle, and the one that got the single mark over here in this one is angle S. So I can say it would be angle S then that it's congruent to. I can also tell that from the congruent statement because M comes first in the first triangle's ordering, and S comes first in the second triangle's ordering. So that's another way to show me which angles are congruent there. Okay, and so down here with number 5, we don't have the triangles, so we're just going to use just the congruent statement to be able to base that off of. So if we have triangle FDE is congruent to triangle FHI, and we want to know side DE in the first triangle would be congruent to what side in the second one? Well, DE comes second and third in the list here. HI comes second and third in the list for the other one. So it'd be congruent to side length H to I, or HI. Okay, so that's that page. Turning the page over. Number 7 and 8, you're marking the angles and sides for each pair of triangles to indicate that they are congruent. So we're going to mark both angles and sides in this. So we have triangle XWV. So X gets single arc, W gets double, V gets triple. And then if I go around and do the side lengths, between angles 1 and 2, or X to W here, single mark there, double mark in between 2 and 3, or between W and V, and then triple mark between 3 back to 1, or that's between V and X. Okay? Go through and do the same thing for the other triangle. So X comes first in that one, so single mark again for X angle in that one. W gets the double, and then J this time gets the triple. Okay, between 1 and 2, we've already put a single mark there, and that makes sense that those two sides it's the same exact side in both those triangles, so that's why they're congruent. 2 to 3 gets the double, and 3 back to 1 gets the triple. Okay, so that would be the way to mark the angles and sides for the triangles there. Okay, and then down for 9 through 12, now you're practicing writing the congruent statement based on the way that the triangles are marked. So this first one, I can say triangle, and then QPR would be congruent to triangle. Q got the single from that one, and then down to P again, and then over to V. Okay, and again, I'm just using the order that the angles were marked with. Single to double to triple, single, double, triple, and then over here, same thing. Single, double, triple, single, double, triple. Okay, for the other two, so this would be triangle K would come first, then L, then J is congruent to triangle R, Q, P. Okay? And so that's writing the congruent statements for those triangles. Okay, going to the next page. Now we're determining if or stating if the polygons are similar or not. So in order for them to be similar, as was stated in the notes, they have to have proportional side lengths. So I'm going to compare the shorter side in this rectangle, which is 42 compared to 54, to the shorter side in this rectangle. So the 42 would compare to the 49. The 54, therefore, would compare to the 63. And I'm going to write a proportion to show that. So 42 is to 49 as 54 is to 63. Since I went smaller to bigger, I have to also go smaller to bigger in my comparison there. Cross multiply. Here's where I'm going to grab a calculator. Multiply 42 times 63, 2,646, and then multiply 49 times 54, 2,646. And because the cross factors were equal, that does show us then that that is yes to being two similar polygons. Okay, 15, same idea. So the longest side in this trapezoid here is going to compare to the longest side in that trapezoid there. And then I can compare the sides, or if I want to use the whole numbers here, I can compare the 28 to the 25. So 54 compares to 45 as 28 does to 25. Cross multiply, so 54 times 25 gives us 1350, and 45 times 28 makes 1260. So because these are not equal to one another, that means that this is going to be a no, that they would not be similar. Even though they appear to be the same shape, have the same interior angles, their side lengths are not proportional, so therefore they're not going to be similar figures. Okay, that's that section. And then the last part of this, on the back side, you're finding the missing side, or the missing length, in each of these similar pairs of polygons. So in this top one, the side of 21 would compare to my question mark here. If I want to change that up, instead of a question mark, if I want to put a variable there like x, I can do that. And then I know that this bottom side would compare to this side here being similar. So the 49 compares to the 42. So when I write my proportion, again to help me solve this, the thing I just need to make sure of is that I'm comparing. If I do small to big, then I have to do small to big here. Or I can do big to small as to big to small. Or I could have even compared this side to that side of the small triangle to this side to that side of the big triangle. Okay. But if I say that x is to 21 as 42 is to 49, now I can cross multiply. Now I'm going to get 49x is equal to 42 times 21, which gives 882. And now divide both sides by 49 to get x by itself. And we get 18. Okay? So that would be that whole side there. Just making a proportion first, comparing two similar sides, and then solving for the variable. Okay, next up, similar figures worksheet. just like what we just saw in the last one. So this is just more practice of the same at the top, determining if the polygons are similar. We're going to then also, it says here, to find the scale factor of the small figure to the large figure. So scale factor wasn't something that wasn't necessarily covered, but in my proportion, I know that the 4 is going to compare to the 12, the 5 compares to the 15. I don't know this side here, but it would compare to the 12 over here as well. So I'm probably going to assume that it's probably 4, since they are similar. Okay, but if I write a scale factor, what a scale factor is how much did the small one have to get multiplied by to make the big one? So because we're asked to write the scale factor from small figure to large figure. So small figure 4 compares to 12, small figure 5 compares to 15. And in each of these, if I were to reduce them, I can divide this one by 4, divide this one by 4, this one divides by 5, this one divided by 5, and so I end up getting a scale factor of 1/3. And so notice that they're both the same here, which is also helping to prove that they are similar figures. So the fact that it's a scale factor of 1/3 means that the larger one was reduced by 1/3 to make the smaller one. Or in reverse, the smaller one was multiplied by 3, so it would be 1/3 is small, or this is 3 times as big as that one. Okay, so that's finding a scale factor. Down here, same idea as the last section in the other worksheet. We're going to solve for x in these, but notice that it's now not just a question mark that's there, it's actually an expression. So that side of x minus 7 would compare to the side of 6 over here in this one. The 6 would compare to the 12. So I can write my proportion, 6's to 12 as, so if I went small to big, then I have to go small to big again. X minus 7 is to 6. Cross multiply, and 6 times 6 is going to make 36 there. And then here's where I have to remember that I'm multiplying 12 times x minus 7, that it's really going to result in a situation like this, which is like distributive property, where I'm going to have to distribute that 12 into the parentheses here, making this 36 is equal to 12x minus 12 times 7, which would be 84. Okay? And now we're going to solve our two-step equation that we've created. So add 84 to both sides first. Let's see, 0 there, 11, 12, so 120 equals 12x. Divide by 12 to both sides, and in this case, x is going to be equal to 10. Okay, so same idea, like solving for a missing side, except for the side this time was not just a single variable, it's an expression, so it creates a little bit more work when you're solving for x. Okay. On the back side of this, a couple more of the same, where you're going to be solving for x with those. And then we get into some where we're finding the missing side lengths. These are a bit more complicated figures, so we have the similar figures. One is embedded within the other. So it's like the conclusion questions that were on the notes. So if I make a comparison here, the small triangle is NDE, the large triangle is NLM. And so in the small triangle, this is my missing side that I'm trying to find, if I call it x there, where the question mark is. And so x, the side of x, is going to compare to this entire side in the bigger triangle, which is shown here as 42. So x is to 42, so those two things compare. And then I can use either comparison of 12 to 36 or 10 to 30. Go ahead and use that one for my other ratio so that I can solve my proportion. Cross multiply here. I get 30x is equal to 420. $420 divided by 30, and that gives us that x is equal to 14. Okay, so these ones are a little bit more complicated. I know for some that it's a little bit more difficult to see what are the two figures and which ones are comparing to which. Okay, but do your best with those. Feel free to come and ask me questions. I think I'll get on Wednesday. I'm going to do another live Google Meet So if we need to go over some more of those problems, we can do that. I'll be posting the rest of the odd answers for these worksheets as well in the next day or two. Down here, so we're being told with a similarity statement which sides are congruent to one another. So if this side u to v comes first in the first one, then that would be similar to side u to m. So that means that the 70 is actually going to compare to the 60 here. My question mark, call it x, would then compare, so since it's v to w, which comes next, it's going to compare to m to n, which is this side here, the 72. So writing my statement, I could say that 70 is to 60 as x is to 72. My proportion, sorry, not my statement there. So writing proportion. And then 60x would be equal to 70 times 72, which is 5,040. Divide by 60 to both sides. And we get that x is equal to 84 here. Okay, so that's that worksheet and how you complete those problems. And then we have similar figures and proportions word problems. So a few word problem application type things for how we could use this. So the first one says a model giraffe is 24 inches tall. If it was built with a scale of 2 inches to 1 foot, then how tall is the giraffe in real life, or the real giraffe? So if I'm comparing model to actual, and I make a proportion out of that, well, from the scale factor that I'm given, I know that for 2 inches in the model, it's 1 foot in the actual real life there for the giraffe. And so the model is 24 total inches tall. Then what I want to know is how many x feet is the giraffe actually. And so now I can cross multiply here. I get 2x is equal to 24. Divide by 2 to both sides, and x will equal 12 feet. Okay, so that's a scale type question. Number 2, a 6 foot tall baby giraffe. A lot of theme here with the giraffe questions. Standing next to an adult giraffe casts a 5 foot shadow. So here we're comparing height of animal to length really of shadow in each of these comparisons. So the baby giraffe was 6 feet tall and it casts a 5 foot shadow. If the adult giraffe casts a 15 foot shadow, or they're 15 feet long for the shadow, so that's the shadow length, going to put that down here, then how tall is the giraffe? So that's the x here. Okay, cross multiply those, we get 5x is equal to...
Are you making a video?
I am making a video, Brindley.
I'm going to try.
Okay. Then divide by 5, and we get 18 feet here for this one. So the adult giraffe would be 18 feet tall here. Okay, let's see, another scale one there. Shadow question there. Let's see if there's any other type of questions in this. Scale, shadow. Oh, here's a map question. Similar idea to the scale drawing one. So Greenwood and Abbott's Rise are 10 inches apart on a map. So map to actual can be the comparisons we make here. So 10 inches on the map, and the scale of the map is 2 inches for every 19 miles. Then how many miles apart are they in the real thing? So x miles there. Cross multiply, you get 190 equals 2x. Divide by 2 both sides, and we get that x would be equal to 95 miles. Okay, so again, hopefully that helps out. There'll be a variety of those types of questions on the quiz for this week. So if you need some help with those, again, reach out to me and or be part of the live Google Meet on Wednesday.